February 20th, 1943, north of Kasserine Pass, Tunisia. No after-action report could ever capture what German tank commanders saw that morning. Out of the dust and smoke, American Sherman tanks began to move, not just advancing, but flowing across the battlefield like one living creature. They weren't using flags, flares, or messengers on motorcycles. Yet somehow, 5 Shermans, separated by rough terrain, unable to see each other, attacked in perfect coordination. Each one covered the other's blind spots as if they shared a single mind. Inside their Panzer IVs, German commanders were fighting their own radios as much as the enemy. Their Fug 5 systems crackled with static, drowning out orders from Company HQ. Those 10-watt transmitters, cutting edge back in the 1930s, barely worked over a few hundred meters once the tanks were moving. Most panzers didn't even have transmitters, only receivers. They could listen, but never reply. Meanwhile, the Americans were using something the Germans didn't even know existed: FM radios. Every single Sherman carried one. Crystal-controlled precision, 25 watts of clean, powerful signal, strong enough to slice through the roar of engines and the chaos of battle like a knife through paper. 8,000 miles away, Detroit's assembly lines had quietly produced the most important advantage of World War II. Not thicker armor or bigger guns, but invisible radio waves that bound every American tank crew into one unified force. The transformation began back on July 22, 1941, when the U.S. Army standardized 3 new Signal Corps radio sets: the SCR-508, SCR-528, and SCR-538. While German tanks rolled across the Soviet Union, relying on fragile AM communication, American engineers at the Galvin Manufacturing Company, soon to be known as Motorola, were perfecting something revolutionary. The team included Daniel E. Noble, who first envisioned FM for battlefield use, and Henryk Magnuski, the lead RF engineer who figured out how to make it work inside the brutal, vibrating shell of a tank. Their creation weighed 181 pounds, and it turned every Sherman into part of the world's first networked army. The BC-604 transmitter pushed 25 watts of power, more than double that of the German Fug 5. Operating between 20 and 27.9 megahertz, it offered 10 preset crystal-controlled channels and paired with dual BC-603 receivers so commanders could monitor multiple frequencies at once, a capability the Germans couldn't even imagine. But the real revolution was frequency modulation itself. Invented by Edwin Armstrong and licensed to the U.S. military, FM eliminated the static and distortion that plagued AM radios. German tank radios turned every spark and gunshot into deafening noise, while American tank crews could talk clearly, even through artillery fire. When Operation Torch landed in North Africa in November 1942, the difference became impossible to ignore. American tanks rolled ashore at Safi and Fadala, equipped with SCR-508s, while the famed Afrika Korps, the Wehrmacht's elite, fought under crippling communication limits. In a standard German platoon of 5 tanks, maybe 1 or 2 had full Fug 5 radios that could transmit and receive. The rest had receivers only. Orders went one way. If the command tank was destroyed, easy to spot thanks to its multiple antennas, the entire platoon went silent. The Americans, on the other hand, could all talk, all lead, all adapt, and that changed everything. During the Battle of Kasserine Pass, from February 14th to 24th, 1943, the world saw the first glimpse of what modern, networked warfare would look like. The Germans might have won the battle on the ground, but they also saw something that terrified them: American tanks maintaining coordination across 50 miles of chaotic terrain. Crews who had never met worked together as if they'd trained for years, warning each other of ambushes, calling in artillery, and shifting formations on the fly, all through crystal-clear radio. German intelligence intercepted those transmissions and couldn't believe their clarity. Reports from the 10th Panzer Division noted that American tanks communicated over distances where German radios could only produce static. And worst of all, they realized that every single Sherman could transmit, not just the commander's tank. The Fug 5, with its 10-watt AM transmitter, could barely reach 2 to 3 kilometers under perfect conditions, and much less when moving. The Americans had simply out-communicated them. The lesson was brutal and simple. In the desert of North Africa, the war for radio waves had already been won.
Every spark plug, every electric motor, every turning track, all of it created interference that old AM radios simply couldn't handle. By September 1943, American tanks were fighting in Italy. The rugged, mountainous terrain should have killed their radio advantage, but instead, it did the opposite. FM technology thrived where the German AM systems completely collapsed. The SCR 508 radios handled the weird echoes and signal reflections of the valleys with ease. American tank crews were talking, moving, and coordinating through terrain where German radios went dead silent. Near Cassino, they advanced through smoke and ridgelines that made visual signals useless, yet their communication stayed crisp and reliable. German observers couldn't believe what they were seeing. American platoons, separated by entire ridgelines, were launching perfectly timed attacks, something German doctrine said was impossible without visual contact. After-action reports from the 1st Armored Division read like science fiction to German intelligence. Crews were coordinating at ranges where German radios produced nothing but static. Then came June 6, 1944, D-Day. As Sherman tanks rolled off the landing craft at Normandy, their SCR 508 radios kept them in touch with naval fire support offshore, coordination that German technology simply couldn't match. But even with this advantage, the brutal hedgerow fighting in Normandy exposed a deadly weakness. The tank radios couldn't talk to infantry radios. The Shermans operated between 20 and 27.9 megahertz, while the infantry's SCR 300 ran on 40 to 48 megahertz, totally incompatible. The result? American soldiers on the ground couldn't warn nearby tanks about enemy ambushes. In the Boguet, those dense, maze-like hedgerows, German infantry armed with Panzerfausts could sneak right up to the tanks, and the men inside had no idea they were coming. The fix came fast. Within weeks, American crews started mounting EE-8 field telephones on the outside of their tanks, wired directly to the internal intercoms. They literally welded ammo boxes to the armor and stuck a phone inside. By Operation Cobra in late July 1944, that simple hack had revolutionized tank infantry teamwork. During Operation Cobra, the 2nd Armored Division under Major General Edward H. Brooks coordinated over 200 Sherman tanks through radio networks that gave commanders near total battlefield control. The German Panzer Lehr Division, once one of Germany's elite armored formations, suddenly found itself fighting an enemy that seemed to have supernatural awareness. American tanks reacted to threats reported miles away. Artillery strikes followed within minutes. In contrast, the Germans were operating in near silence. Most of their tanks had no radios at all, relying on hand signals or colored flares, useless in the hedgerows where visibility was often less than 100 meters. Those few functioning radios still in use were crippled by static and short range. The irony was staggering. Germany had invented modern tank warfare. General Heinz Guderian, the father of Blitzkrieg, had pushed for radios in every tank as early as the 1920s. His 1937 book, Achtung, Panzer, had made one thing clear: communication was everything. Fast-moving armor was only as good as its ability to coordinate. But by 1943, the same German industry that built those doctrines couldn't keep up. Production data told the story. In 1943, Germany built about 5,700 medium tanks, but fewer than 2,000 Fug transceivers. Most of those went to command tanks or assault guns, leaving ordinary panzer crews cut off from each other. The Soviets were in even worse shape. Their legendary T-34s, despite being produced in massive numbers, often went into battle with no radios at all, just flags and prearranged plans. In 1941, it was a disaster. By 1943, American Lend-Lease shipments helped a little. Some Soviet command tanks were fitted with SCR-508 sets, but even by the end of the war, only about 1 in 4 Soviet tanks had any kind of radio. The contrast couldn't have been sharper. While the Soviet Union struggled to give even 25% of its tanks basic communications, America achieved 100% coverage. Every Sherman, every crew, every fight. At the heart of it all was Motorola's Chicago factory, once just a car radio company. Before the war, they made consumer electronics. But when the call came, they retooled overnight, transforming civilian expertise into one of the most decisive technological edges of World War II.
Each SCR-508 radio was a masterpiece of wartime engineering. 2,748 individual components, all built to precision standards. Just the BC-604 transmitter alone contained 474 capacitors and 385 resistors. Its crystal oscillators had to hold exact frequencies through brutal heat, freezing cold, and non-stop vibration inside a tank. The numbers told the story of American industry in motion. 1942, 3,800 units. 1943, 11,400. 1944, 24,000. By the end of the war, over 50,000 tank radio sets had rolled off American assembly lines, enough to equip every one of the 49,000 Sherman tanks produced. No other nation even came close. But the SCR-508's edge wasn't just about having radios in every tank. It was about how those radios worked. Its crystal-controlled frequencies stayed perfectly stable, even in the chaos of combat. Crews could preset channels before a mission and know they'd stay aligned under fire. By contrast, German FUG-5 radios used manual tuning, variable capacitors that constantly drifted off frequency. Commanders had to keep fiddling with dials just to stay connected. American commanders, meanwhile, could monitor 2 networks at once, one for their platoon and another for company command. Orders and reports flowed instantly in both directions. The BC-604 intercom linked every crew member, letting gunners, loaders, and drivers shout warnings directly to the commander through throat mics and noise-canceling headsets, something many German tanks didn't even have. Their crews literally had to kick each other or yell over engine noise to communicate. Power was another quiet advantage. The SCR-508 could run on 12 or 24 volts, automatically adjusting to whatever was available. Its dynamo power supply filtered out interference, so every spark or engine surge didn't come through as static. German radios, powered straight from the vehicle's electrical system, had no such protection. Every ignition spark turned into noise on the line. These small differences added up to a complete transformation in doctrine. American tank forces could form flexible, improvised battle groups, mixed units of tanks, infantry, and artillery, because their radios were always compatible. German formations, locked into rigid hierarchies, couldn't adapt the same way. That difference became painfully clear at the Battle of Arcourt, September 1944. The U.S. 4th Armored Division faced multiple German panzer brigades armed with the superior Panther tanks. On paper, the Germans had the edge in firepower and armor. But the Americans had something far more decisive: communication. Every Sherman could instantly report an enemy sighting. Tank destroyers miles away received precise target updates. Artillery observers inside command Shermans called in devastating fire missions within minutes. The result? In 3 weeks, the 4th Armored destroyed 281 German armored vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that completely defied the specs on paper. Yet German intelligence never understood why. Their reports described excellent American coordination, but credited it to discipline and training, not technology. A captured intelligence memo from September 1944 read, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." They had no idea the secret was sitting right there inside every Sherman. Because they never adapted, German tactics stayed frozen in time. They kept targeting command tanks, easy to spot by their multiple antennas, not realizing that now every Sherman could act as a command tank. They planned ambushes assuming American platoons would lose coordination once out of sight. But the radio nets kept them unified, no matter how scattered the battlefield became. By March 1945, as American forces approached the Rhine, that communication supremacy reached its peak. The capture of the Remagen Bridge showed how fast American command and control could react. When the 9th Armored Division found the Ludendorff Bridge still standing, the report reached 1st Army headquarters within minutes. Within an hour, entire divisions were shifting their movements to seize the opportunity. German units, dependent on telephone lines already shattered by Allied air attacks, couldn't respond. Their counterattacks came too late, uncoordinated, fragmented, and easily crushed. By April 1945, during the encirclement of the Ruhr Pocket, American forces perfected the art of radio-driven warfare. Armored columns from the 1st and 9th Armies executed a double envelopment entirely through radio coordination. No messengers, no guesswork, just instant, networked command. For the first time in history, war had gone wireless, and America was the one holding the signal.
Inside the Ruhr Pocket, 325,000 German troops found themselves trapped, partly because their communications had completely collapsed. American fighter bombers, guided by forward air controllers using radios, systematically destroyed every German command post and relay station. The Wehrmacht lost contact with its higher headquarters, and soon with itself. Field Marshal Walter Model's final messages before radio silence said it all. No contact with adjacent units, no communication with higher headquarters, fighting continues, but coordination impossible. It was the end of an army, not because they ran out of bullets, but because they ran out of connection. For American crews, that connection made all the difference. They fought knowing they were never truly alone. Even isolated on the battlefield, they were still part of something bigger, a living, breathing network of steel and voices. German tankers experienced the opposite. Cut off and deaf to each other, they fought individual, desperate battles, each crew alone inside the chaos. Otto Carius, one of Germany's greatest tank aces, later wrote about this in his memoir, Tigers in the Mud. He focused on tactics, but between the lines you can feel the frustration of fighting blind, in a war where communication had become the ultimate weapon. And that weapon decided the tempo of the entire campaign. From 1944 to 1945, American advances rolled forward faster than the Germans could react, powered by a web of radio networks that stretched hundreds of miles. General Patton's Third Army raced across France not because it had faster tanks, but because every movement, every artillery strike, every resupply was coordinated through the airwaves. The Germans never fully understood it. They couldn't imagine communication on that scale. Even Heinz Guderian, now Inspector General of Armored Troops, saw the problem but couldn't fix it.
In a memo from December 1944, he admitted that American coordination had erased Germany's advantage in tank design and armor quality. After the surrender, American technical teams finally got their hands on German equipment. Their reports confirmed what the battlefield had already shown. German tanks were beautifully engineered, but their radios were hopelessly outdated. U.S. Army Technical Intelligence Report number 176 summed it up bluntly. German tank communications are approximately 5 years behind U.S. systems. No FM capability, poor electrical shielding, constant interference, and too few sets to go around. Even the Soviets agreed. Given access to captured German technology, Red Army engineers decided not to copy it. Instead, they modeled their post-war radios after the American SCR 508 design. The numbers told the whole story. American SCR 508, 528, 538 radios produced 50,000 plus. Sherman tanks produced 49,324. Radio deployment 100%. Power 25 watts. Crystal frequency stability plus or minus 0.01%. Range up to 10 to 15 miles when stationary. Now compare that to Germany. FUG-5 radios produced about 6,000. Medium and heavy tanks built around 12,000. Full transceiver deployment only 20%. Power 10 watts. Stability plus or minus 1%. Range barely a mile on the move. The results spoke for themselves. Average American fire mission 3 to 5 minutes from request to impact. Average German fire mission 15 to 30 minutes. American tank coordination 100%. German tank coordination 20%. That difference, the ability to connect faster, clearer, and universally, changed warfare forever. The radio superiority of the Sherman established principles that still define modern armored warfare. Today's main battle tanks use digital systems, not analog, but they follow the same rule. Universal communication beats individual power. When the Bundeswehr was formed in the 1950s, West Germany's new army took that lesson to heart. Every Leopard tank rolled out with state-of-the-art communication gear. A Bundeswehr training manual put it perfectly. The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority. And history has proven it again and again. In the 1991 Gulf War, coalition tanks with advanced communication systems wiped out Iraqi forces armed with technically stronger Soviet-built machines, but crippled by poor coordination. In 2003, the same principle held true. Network-centric warfare, the direct descendant of the Sherman's SCR 508, once again defeated platform-centric warfare. The tanks changed, the radios evolved, but the lesson remained the same. The side that talks faster wins.
The story of the Sherman tank's radios isn't just about engineering. It's about a victory in the invisible realm of the electromagnetic spectrum, a triumph that proved more decisive than any edge in armor or firepower. German tank crews fought their war half blind to this revolution. They discovered too late that every American Sherman wasn't just a tank. It was a node in the world's first battlefield network. The SCR 508 radio transformed the M4 Sherman from a decent, mass-produced medium tank into part of a much larger system, a connected, coordinated force. That transformation mattered more than any upgrade in guns or armor ever could. Each Sherman carried its real weapon not just in its 75mm cannon, but in the 181 pounds of radio equipment that linked its crew to every other American tank on the battlefield. Together, those connections created something entirely new, a kind of collective intelligence that no isolated German tank, no matter how advanced, could match. The Germans learned this lesson the hard way at Kasserine Pass, in Italy's mountains, across France's hedgerows, and in the final battles inside Germany itself. Everywhere, American tanks moved, fought, and adapted with a level of coordination that German doctrine said was impossible without visual contact. And they never found an answer. The Wehrmacht never developed an effective countermeasure because they never truly understood what was happening. At the war's end, Field Marshal Wilhelm Keitel reportedly remarked, "We knew how to build better tanks. You knew how to make them work together." Whether he actually said it or not doesn't matter, because it captured the truth. America hadn't just built 49,324 Shermans. It had built 49,324 connected machines woven together by radio into a single, thinking, coordinated force. Historians often credit the modern idea of network-centric warfare to the digital age, to satellites, data links, and computers. But in reality, that revolution began in 1942, the moment the first Sherman tank with an SCR 508 rolled into combat. From that point on, war itself had changed. The side with better communication would defeat the side with better weapons. The network would defeat the platform, and the connected would always overcome the isolated. The tragedy for Germany was that by the time its commanders realized what the Americans had, that every Sherman tank could communicate while most of theirs could not, the war was already decided. It remains one of the great intelligence failures of the Second World War. Even after countless battles proved how effectively the Americans coordinated, German leadership never made communications their priority. They kept building magnificent machines, superior tanks that fought as individuals, while the Americans built adequate tanks that fought as teams. In the end, the invisible radio waves carried by the SCR 508 proved deadlier than the German 88mm shells. The power to coordinate, to share information, to move as one, that unseen advantage was stronger than any armor ever forged. The Sherman's radio superiority didn't just win battles, it changed warfare forever, establishing a principle that still defines combat today. Connection means survival. Isolation means defeat. Across 3 continents, the Germans learned that lesson the hard way, realizing too late that the Americans' true strength wasn't just in their numbers, but in their signal.